properties of the definite integral. These are all going to be very, very familiar because, again, integration is just a fancy form of summation. That's it. These summation symbols, everything that we do for summation, we can do for the integral. That's all. Okay. The integral from b to a of f of x dx is equal to the negative of the integral from a to b of f of x dx. In other words, if I switch the order of integration, if I do here, I would do my delta x is b minus a over n. Here, I'm sorry, here it's b minus a over n. Here it's going to be a minus b over n. If I integrate from b to a instead of from a to b, all I do is switch the sign of the integral. That's it. Very, very simple. That is all. Because in calculus, we're adding from left to right. We have some function. Remember, we broke it up into a bunch of rectangles. If I add in this direction from a to b, I get a number. If I decide to add in this direction, I get the negative of that number. That's all this is saying. Switch the upper and lower limit, change the sign. That's all. The integral from a to a of f of x dx, that's equal to 0. The integral from a to b of c dx, c is any constant, well, that's just equal to c times b minus a. All this says is, if I have a constant function from a to b, the integral, well, it's just c, the value of c, which is this height, times this distance, the area. Or it could be negative, because again, it's just the integral. So now we're thinking, so areas can now be negative. So now we've introduced this notion of a negative area. It's not a problem. Okay, some further properties. The integral from a to b of c times f of x dx, again, you can pull the constant out, c times the integral from a to b of f of x dx. The integral from a to b of f of x plus g of x dx, the integral of a sum is equal to the sum of the individual integrals. In other words, the integral sign distributes over both. The integral from a to b of f dx, you know what, just write out the whole thing, sorry, of f of x dx plus the integral from a to b of g of x dx. And the integral from a to c of f of x dx equals the integral from a to b of f of x dx plus the integral from b to c of f of x dx. What this last one says, I can actually break this up. If I have a here, and if I have c here, and if I have b here, and if that's my function, the integral from a to c is just the integral from a to b plus the integral from b to c. That's all. That's all I'm doing. Just adding them up. Okay. Now, if f of x is greater than or equal to 0 on the interval ab, then the integral of f of x dx is greater than or equal to 0. Very, very simple. Nothing happening here. Very, very, very simple. Integration is something called an operator. And an operator is just a fancy word for do something to this function. In other words, operate on it. If I give you a function f of x and I say integrate it, well, integrate it means do something to it. Take this function through a series of steps and spit out a number at the end. That's it. So when you see f of x is greater than or equal to 0, you already know from years and years and years of, elementary and junior high school math, that whenever you have an equality, or an inequality, as long as you do the same thing to both sides of the equality or the inequality, you retain that equality or inequality. Here, f of x is greater than or equal to 0. Well, if I integrate the left side, integrate the right side, I get the left side is the integral of f of x dx. The integral of 0 is just a bunch of zeros added together. It's 0. So it stays. That's it. So think about it that way. When you see an equality or an inequality, you can integrate both sides. It retains the equality or inequality. It retains the relationship. Just like if you take the logarithm of both sides, if you exponentiate both sides, if you multiply both sides by 2, if you divide both sides by 5, as long as you do it to both sides, you're fine. Treat the integral as some operator, as something that you do. Okay. If f of x is greater than or equal to g of x on AB, then exactly what you think. The integral from a to b of f of x is greater than or equal to the integral from a to b of g of x. That's it. This is greater than that, so the integral is greater than the integral. Very simple. If m is less than or equal to f of x less than or equal to capital M on AB, then m times b minus a less than or equal to the integral a to b f of x dx less than or equal to m times b minus a. If some function on this interval happens to have a lower bound and an upper bound, then the integral of that function is going to be greater than the lower bound times the length of the interval. It's going to be less than the upper bound times the length of the interval. Again, all we've done here is take the integral of this, the integral of that, and the integral of that. Well, the integral of that, that's this symbol. The integral of a constant m dx, well, we said is equal to m times b minus a. The integral of m, capital M, is capital M times b minus a. That's it. Just integrate, 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 solve for the things you can solve, and leave those that you cannot as the symbol. Okay, thank you so much for joining us here at Educator.com. We'll see you next time. Bye-bye.